Good morning, learners. My name is Mr. SOHCAHTOA once again. Your host and teacher on Black Slides online learning platform. By the grace of God, I'm your teacher of physics, chemistry, biology, and mathematics. We meet today for a topic in mathematics, a topic called sine and cosine rule. This is a topic in Form 4 mathematics. It is an extension of a Form 3 topic which is called the trigonometry 1. So trigonometry 1 in Form 3 is a topic that you already covered and gave you some background, some basics of trigonometry. So in Form 3, you learned what is commonly known as SOHCAHTOA, which is an acronym or a shorthand notation of three trigonometrical ratios, which are called sine, cosine, and tangent. You will recall that SOHCAHTOA is a very powerful tool when it comes to solving right-angled triangles. So you use the SOHCAHTOA to either find a known side of a right-angled triangle or an unknown angle, strictly for a triangle that contains or has a 90-degree angle in it. So further to SOHCAHTOA, we have what we call sine and the cosine rule. Sine and cosine rules are very powerful tools which you can use to solve for any triangle. Triangles other than right-angled triangles. So you can use sine and cosine rules to either find an unknown side or an unknown angle for any kind of triangle, be it acute angled triangle, obtuse angled triangle, or any other triangle other than the one that has a right angle in it. So this happens to be lesson number 1. Let me welcome you to the lesson. And as you can see on the screen, I have my calculator ready. And I would also request that you have your own calculator with you by the side, because you're going to be following only the calculations. It is important that as we look at examples, you also follow suit. So get your calculator ready, and as well as your notebook in which you be required to copy examples as they come. Welcome. So once again, in case you're just joining us, my name is Mr. SOHCAHTOA, your online teacher. I take you for physics, chemistry, biology, and mathematics. So this is time for mathematics. Regardless of the school you attend, You are free to learn for free without paying any fees. So these are free lessons. All right, you can pay school fees elsewhere, but as far as you are learning from this platform, you don't need to pay any dime. So when you have completed the topic, you should be able to use the sine rule to find the length of a triangle, an unknown length of a triangle. All right, you should be able to use the sine rule to find an unknown angle. Okay, you should be able to use the cosine rule to find an unknown length, and also to use the cosine rule to find an unknown angle. Later on, we are going to look at what is known as the area formula. The area formula, we are going to derive the area formula and use it to find the area of any triangle other than a right-angled triangle. You do recall that for a right-angled triangle, to find the area of a triangle, you simply use the formula half base times height. You are familiar with that, I guess. So area of a triangle is half the base of the right-angled triangle multiplied by its height. This applies to a right-angled triangle. But what about if a triangle does not contain a right angle in it? How do you work out its area? So we are going to look at that. And then we are going to look at mixed problems in which we are going to apply the sine rule, the cosine rule, and the area triangle to solve miscellaneous problems. So once again, you are most welcome. Please get settled and keep me company and follow on every discussion, follow on examples, pay attention carefully, listen very attentively, and make sure that you are able to work on problems as they come in the topic. All right. So once again, this is an extension of a topic which is trigonometry, which we encountered for the first time in Form 3. All right, so it's we can call this trigonometry 2. So trigonometry 1 you learned in Form 3. In order for you not to miss any lessons or videos, hit the notification bell, subscribe to the channel, to the YouTube channel, where you are learning all these subjects, so that whenever a new lesson is uploaded, you are able to get a notification. Great. So let's now dive into the sine rule. What does the sine rule state? All right, what is the sine rule? What is the sine rule? What does it state? All right, so the reason why you have to learn this part, this topic, is for you to be able to show that to show how to use the sine rule to solve real-life problems involving finding the length of a side of a triangle. All right, so the sine rule is going to help you to solve real-life problems involving finding the length of a side of a triangle as well as an unknown angle. So it is hoped that in this lesson you are going to know how to use the sine rule and solve real-life problems involving lengths of triangles as well as angles of triangles. So this is what you are expected to achieve in this lesson number 1. All right, to know how to use the sine rule to solve real-life problems involving lengths of triangles. All right, so what is the sine rule? Or what does the sine rule state? So the sine rule is basically a relationship. It's an equation, mathematical equation, that relates to a triangle, to the angles of a triangle and the size of the triangle. Any triangle. Let's, for example, look at this triangle here. This is triangle labeled A, B, C, and like that. So we have A, B, sides A, triangle A, B, C. All right. Now, if you look at this triangle ABC, the side which is opposite this side here, which is facing the angle A, is marked with the letter A, small a. All right, so this side BC is directly opposite, is facing, or it is subtending the angle A. So we call it small a. The angle here is capital A. The side subtending that angle is small a. I hope we are together there. Similarly, the angle B is facing the side AC. So side AC is marked with the letter B, which is the side subtending the angle, the capital letter B up there, which is the angle at that point. And then angle C, represented by the capital letter C, is subtended by the small letter, or the side marked with the small letter C. So we are saying we have a triangle ABC with sides A, B, C. Take note of that. So this A, small a, is subtending or facing the angle marked A, while this angle here, this side here, this side B, is subtending or facing the angle marked B, and this angle capital C is being subtended by a small c, the side marked with the letter C. All right, so the sine rule states that with this given triangle, the ratio of side A, to sine of angle A. Angle A is this one here. So we are saying A, the side marked A, divided by or over the sine of angle A is equal to side B is this one, over the sine of the angle which the side B is facing, and also equal to side C over angle marked C. That's what the sine rule states. So if we are given enough information, we can use the sine rule with any type of triangle. even the right-angled triangle, you can also use it. So instead of using the Pythagoras theorem, you can apply the sine rule as well, and you still get the answers, the length or the angle that is required. So the sine rule, therefore, applies to all types of triangles, regardless of the angle present in them. All right. So this is the sine rule. It also follows that if we take the signs up, suppose we take the sine up and we bring the size down, it will also follow that sine A over side A is equal to sine B over B, and so on. So then sine C over side C. All right, it applies. So we are saying if you take the reciprocals of the fractions, it will still hold. It's the same. It has the same significance and meaning. All right. So let's see how this rule, the sine rule, is arrived at, is derived. How do you show that this is true from the basics? So let's look at the derivation, or how the sine rule can be derived. To derive means to use what you know to obtain the equation that is intended. All right, so let's suppose that we have triangle ABC. All right, so we have triangle ABC. Take note that the capital letters represent angles. So we have angle A, angle B, and angle C. So here we have angle C. All right, and that angle A is being subtended or faced by side A, this one here. So this side is facing directly, or subtending this angle. Very important to note that. Similarly, angle B, this one here, is being faced or subtended by side B. So side B is facing angle B. And finally, side C is this one, this side here, is facing directly that angle. All right, so consider this triangle with the given information. You draw a perpendicular, which is also called an altitude, CP, so that it is perpendicular to BA, like that. So you draw a line from C to any point P so that it's perpendicular. To be perpendicular means to form a 90-degree angle. So angle CP, line CP perpendicular to BA. All right, meeting at a 90-degree angle. This is meeting at a 90-degree angle on BA. All right, so we have two triangles in this case. If you look at carefully, you have triangle ACP, and triangle BCP. So we have two triangles if you look at this carefully. Right. So Using SOHCAHTOA, which you are already familiar with, using SOHCAHTOA, the sine of angle B, the sine of angle B, this one here, is equal to side CP, which is the opposite side. This is the opposite side, divided by side A, which is the hypotenuse. Remember definition of sine. Sine is the opposite side divided by the hypotenuse side. So in this case, the side which is opposite to angle B is side CP, this one here. And the hypotenuse is side marked A. That is if you are looking at this small triangle here. So if you make from this, you can make CP the subject of the formula. CP the subject of the formula. All you do is multiply both sides of this equation by A. All right, so what we are saying is to make CP the subject. To make CP the subject, so we are saying sine B sine B is equal to CP over A. So to make CP the subject, all you have to do is multiply both sides by A, and this will give you, if you multiply both sides by A, it means this A here will cancel that, and so the result is going to be CP equals to A sine of B. Mind you, we are just using SOHCAHTOA, which you learned in form 3. All right, so we are saying from that, CP made the subject of the formula will be equal to A sine B. Similarly, if you take sine of angle A, again applying SOHCAHTOA, this angle here, the sine of this angle is equal to the opposite side again. So our opposite side is CP, opposite is CP, the hypotenuse is the side marked with the letter B. So we are saying sine A is side CP, the same side as before, over the hypotenuse. This time we are paying our attention to triangle ACP. So CP, making CP the subject, will give us CP equals to B sine A. Just multiply both sides by B, it will give you CP equals to B sine A. All right, so you can see here that CP is equal to A sine B, and the same CP is equal to B sine A. What does this mean? It follows that sine A sine B should be equal to B sine A. A sine B is equal to B sine A, because both are equal to the same length there, which is CP. So CP is equal to A sine B, CP is equal to B sine A, therefore A sine B should be equal to B sine A. I hope we are together there. If I'm fast, please indicate in the comment so that I can address your concern. So if we solve this equation for A, rather for B, meaning that we make B the subject of the formula, all you have to do is divide both sides of this equation by sine A. If you divide this side by sine A, and also this side by sine A, then you have this one here. What we are saying is, we have from above there, we are saying A sine B is equal to B sine A. B sine A. So if you divide both sides by sine A, if you divide both sides by sine A, divide also this side by sine A. So this sine A and this sine A are going to disappear, so that you have what you have now is just a B, which is equal to A sine B, this one here, A sine B over sine A. That's what we have over there. Right. Unless you are not sure, please let me know. So the same, if you divide both sides by B, then you are going to have this equation here, A over sine A being equal to B over sine B. All right, so we have obtained. You can follow on the steps until you are convinced that indeed sine A over is equal to B sine B. So by extension, it will follow that A sine A is equal to B sine B, and also C is over sine C. A over sine A is equal to B over sine B equals to C over sine C. That's basically what we are saying. But this is also equivalent to A sine A over A equal to sine B over B equal to sine C over C. I hope you are able to follow on the steps to derive the sine formula. So either this equation here, or this one here, both of them are true for the sine rule. All right, now it is time for us to look at how the sine rule can be made use of in solving triangles, calculating sides using the sine rule. All right, so we have an example here. Find the length A. So we have the length A here in this triangle. This is triangle ABC. Triangle ABC. All right. So we are given the sides. AB is 10. And then we are given angle A as 41 degrees and angle C as 34 degrees. So first and foremost, we need to mark our triangles, the corresponding sides. All right. So this angle A is opposite that side there. In other words, this side BC, which is marked A, is facing this angle. So we have a capital A there, we have a small a there to represent the side, because this side is directly facing or subtending angle A. Similarly, the angle marked C, this one here, is directly subtending this side. So this is our side C. This is C. So C, side C is side C is equal to 10. So C, small c, it has to be a small c. Small c is equal to 10 centimeters or 10 meters. Okay, why? Because why this needs to be C, small c, is because it's opposite that angle there. Yeah, so we can write down our sine rule. So sine rule states that, oh, by the way, before we proceed, this is supposed to be a small b, this side. All right, so according to the sine rule, we are saying A over sine A is equal to B over sine B, and this is equal to C over sine C. All right. So substituting the given values, A, we don't know the value of A, we are not told this is, and this is the one that we need to work on, but at least we know the angle A, so we can substitute the angle A with the 41. So place 41 here, and side B we don't know, angle B we don't know as well, so the whole of this is not known, but side C is known, is 10 meters, and side C is also, angle C is also known, is 34 degrees. So in this case, we know angle A, we know side C, we also know angle C, but we don't know side B and angle B. We don't know. So we can equate this part here to this part here, and then solve for A. So to do that, all we have to do is isolate A over sine 41, and C over sine C. But side C is given as 10, while angle C is given as 34. So the only unknown here is the letter A, this one. So we need to solve for A. We need to solve for A. That's what the question is asking us to do. So if you rearrange the equation and solve for A, or make A the subject, you are going to have something like this. So we are saying making A the subject, or solving this equation for A, it's going to give us this relationship. So we are saying A is equal to 10 multiplied by sine of 41 divided by sine of 34. Please convince yourself how we get to this one. Just make A the subject of the formula. You do cross multiplication and then you solve for A. You get this relationship here. So let's punch this one using your calculator. You can punch this one on your calculator and see what you get. So on my calculator here, we have 10 multiplied by the sine of 41, then divide this by the sine of 34, Make sure to make correct substitutions. So solving for this, you actually appreciate that we get the value of A as 11.7. So we are saying the result is going to be 11.7. Please check the calculator value and the one we have here. Check that they are matching. Of course, maybe the calculator has rounded off. This is 11.73, which is the same, almost the same as the one we have here, 11.74. I had some round off to do. So this was a rounded off value to 2 decimal places. So the calculator value and the one we have here should be the same. Please convince yourself that you are able to do this on your calculator, because that's what you'll be required to do in an exam as well. All right, let's look at another example. In this example, we are asked to find the length D, in this triangle. So this is triangle CDE, in which we are given the angle C as 37 the angle D as 133 degrees, and the side C, mind you, this is side C. Maybe you should label them accordingly. So this is this side here is small c. Why small c? Because it is subtending that angle there. This angle is being subtended by an E, that side. But we don't know what E is. The angle E and the side E are not given. All right, so the side we need to find is this one here, okay, which is opposite that. Mind you, the small letters should match with the capital letters, the D's. The D, then you have C, E, and so on. All right. So matching the corresponding angles and sides, we are going to have, as shown in the diagram there. So this side here is opposite this angle. So this is small c being equal to 10 meters. Then you have capital D there. The angle is subtending this side D, which you don't know. Okay, so and we are asked to work it out. So first and foremost, you write down your equation, which is the sine rule. So the sine rule which is applicable to here, to this situation here, is going to be c, small c, this one, this side, over sine of capital C, sine of capital C, which is this angle, being equal to small d, d, this one here, divided by sine of capital D, that one up there, being equal to E, this one, this side, over sine of E, which is the sine of this angle here. And so you can see that we don't know the value of D, but we know angle D. Angle D is given. All right. We also know the value of side C. You see 10 up there. And we also know the angle C. It's given here. So, but we have no business with the last part here, E over sine E, because none of them, neither E small e nor capital E are given. All right, so we proceed to bring these two together, equate them. By equating them, so we equate this one to this one, and not to this one, because this is not known. We don't know E, both E's. All right. So next, if you solve for D, you are going to have D expressed as the subject of the formula. Just all you do is just cross multiply these, and then make D the subject of the formula. You get this one here. You get 10 times the sine of 133 divided by sine of 37. All right, so once again, using your calculator, let's clear the work that we had earlier on. So using your calculator, we are saying we have 10 multiplied by the sine of 133 divided by the sine of 37, the sine of 37. So this should give us 12.15. If our calculation is correct, we should have 12.15 or 12.14. Okay, don't worry, 12.14 or 12.15 is basically the same. The difference is just the rounding off of the third digit. All right, very, very important to note. I'm sure you can now appreciate the usefulness of the sine rule. You can solve for any triangle, solve for side of any triangle, regardless of where the angles that are in it, be it right angle, obtuse angles, acute angles, and any other angles. So this is a very, very powerful tool very useful tool for solving triangles. All right, so for lesson 1, we'd like to stop here. Thank you very much for your undivided attention. I want to leave this work with you to work on, and I'll be glad if you can share the answers. Share the answers with me so that I also ascertain that you are following on and you have understood the lesson. When we meet again, we are going to look at how you can use the sine rule. The sine rule to calculate angles. In today's lesson, we're looking at how the sine rule works when it comes to calculating lengths of triangles, unknown lengths of triangles. Once again, thank you very much. I look forward to meeting you again in the next lesson, which is lesson number 2. Bye for now.